Okay, so here is, I'm going to walk you through how to make your calculations for the final, okay? Mass of your car with egg, right? You should add up, obviously, your empty car and the egg together. Okay, so let's say that I get 100 grams for this. Your numbers are going to be different, right? Okay, you need to make sure that you change that into kilograms, right? So there's 1,000 grams in 1 kilogram, okay? So you need to have this in kilograms, whatever your mass is. All right, so make sure that that gets into kilograms, okay? You can describe the motion of the car. I think you can do that yourself. Okay, then you're going to find the average velocity. So we labeled the length in class. Okay, so I'm just going to say it was 6 meters. It was a little off from that, but, you know, this is just an example. Okay, and let's say the time that it takes to get down your ramp, let's say it was 2 seconds. Okay, and again, your numbers are going to be different than these, okay? Whatever yours were. All right? Okay, so we know that average velocity is displacement over time. We learned that way back in September. Okay, so if I want to calculate here, my average velocity, okay, is going to be delta x over delta t, okay, and then whatever it is for you, right? So it should be around like, 2, 3, 4 meters per second, somewhere in that range, okay? All right, so make sure that you show this work and make sure you include units, okay? Because there's not that much to do for this final, so what you do needs to look really good, okay? All right, so that's how you get the average velocity. All right, now, we don't want the average velocity, we want the velocity at the bottom, right? So I have the initial velocity at the top is 0, and the final velocity here is the one that we want, right? Because this is going to be at start of collision, all right? So that's what we want, okay? So the way we can figure that out, if we know here that the average velocity was 3 meters per second, okay? Average velocity just means you average literally the velocities, okay? Initial and final divided by 2, all right? So our initial velocity is going to be 0, okay? So it just turns out that the final velocity divided by 2 is the average, right? Because it's like if I have a 100 and a 0 on tests, right, then my average is a 50, okay? And then I want to solve for this, okay? So I'm just going to let you figure that out, but I'm trying to solve for VF here, okay? All right, and then my average velocity is that one, all right? And I'm just solving for VF, okay? All right, so that's that. All right, once you get that that final velocity, okay, that actually becomes the initial velocity for the collision, okay? So this is VI for the collision, right? Because it's in 2 parts. So the first part of the experiment is as it goes down the ramp, okay? And then the second part of the experiment is what happens during the collision, all right? So this VF here turns into the VI for the collision, okay? All right, next page. Once you get your maximum force, let's say it was like negative 18 newtons or something, right? And it needs to be negative, right? Because if the car is moving this way, right, the velocity is this way, when it gets hit by that force sensor, that force is going to be pointing in the other direction, okay? So that needs to be a negative, okay? All right, so here I'm going to have F times T equals M, VF minus VI, all right, to get the time. So this is what you're trying to calculate, okay? And then the final velocity in the collision is going to be 0, right? Because we're going to assume that we're only looking up until it stops. And it might bounce back or something, but we're just going to look at until it stops, okay? So this is the force that you get from your sensor. Okay, this is your mass. Make sure, remember, it needs to be in kilograms, okay? And this is calculated from last page, right? What was the VF was VF, okay? Right? So then you need to crank out these calculations and show that the time equals whatever, okay? And show the work and include units, all right? Okay, and I'm just going to let you figure that out because I don't want to do the whole entire thing for you, okay? But VF is going to be 0, so you're going to plug in your F from the sensor, your mass, and your VI, okay? All right, if I want to calculate the force of gravity on the object, okay, it might make more sense to first draw your force diagram, okay? Let's assume that the car was going this direction, okay? And then you need to draw and label on, whatever the forces are. Draw and label, okay? With numbers. So I want numbers and labels, like FG, right? FG, cart, earth, whatever, and I want those numbers, okay? And then you draw the rest, right? I'm not going to draw the whole thing for you, but you draw the rest. let's assume there's no friction during the crash, okay? And I want this at the time that it hits the force sensor, okay? Even though it's kind of coming in at an angle, let's just kind of pretend it's coming in straight because it's a little easier for us, okay? We don't have to worry about friction. I just want to see what the forces look like during the crash, okay? And then you need to tell me if they're balanced or unbalanced and how do you know, okay? And explain during the crash. So remember, again, this is during the crash, okay, while it's hitting the sensor. While car is hitting sensor, okay? All right, okay, now once you've drawn the force diagram, remember your force of gravity is going to be mass times the gravitational field strength, okay? Remember to use kilograms again, okay? And then you're going to crank out that calculation and tell me how many newtons your car weighs, all right? And that is it. So I don't think it's going to be horribly taxing, okay? Here, for this calculation, I'm also going to say watch the negatives, okay, right? Because your time should come out positive, obviously. Okay, and then, you know, I can kind of help you with that next week, all right? But if you want to have time to build extra cars or whatever, then if you kind of get at least this started and sort of cranked out, then you'll be all set for next week, okay? I think that should do it.